I'm back working on this ASR33 teletype. In this series of videos so far, I've completely stripped this unit down. I've rebuilt the keyboard, rebuilt, repaired and got the printer largely working. It's working fairly well now. It misses the occasional character. I think the timing still needs setting, but really it just needs using for a while before I make any further adjustments. I've been through the electronics pack, that's all working fine. So I've only found a few minor faults with this. It's mostly been okay. It was really just a case of it hadn't been used for a very long time and the whole thing had kind of seized up and wasn't working. There was some damage, there were various bent parts, but mostly it just needed lubricating and freeing up. So this is now largely working. The next thing I'm going to address is the paper tape punch. So we'll get the printer out of the way and we'll start working on this. Okay, so this is the ASR33 paper tape punch, and there are no electronic parts on this. It's purely mechanical, and the way it works is there's a rocker bar which attaches to this pin here, and that's meant to move back and forth and operate the punch mechanism. And the character it punches is controlled with these slides, so each one of these is responsible for enabling or disabling one of the punch pins, which are at the front here, and depending on the position of these slide bars will determine whether a particular pin is used in a particular punch cycle. Now this is completely seized up, I can't get it to move at all. And so what I'm going to do, as ever, is take it away, give it a clean, and then we'll try and figure out why it's seized up and see what we can do about it. Although there's rust on here, you need to be very careful. Do not put it in a tank of evaporust. Some of the parts are painted, but most of them are black oxide coated, so you'd end up taking all the black oxide coat off and then the entire thing would rust in a couple of days. So what I'm going to do is take it away, clean it, dry it, and then try to free it up. It's almost certainly just stuck with age, so it will just literally be a case of freeing up each of the moving parts individually. Now of course when you pull this pin across, it's trying to operate the entire mechanism, all the linkages, levers, everything. And it requires a lot of force to free them off. You probably break something, but if you work on them individually, carefully free them up, bit of lubricant, then by the time you've worked your way through all the various linkages, levers, make sure the punch pins are freed up, then you'll probably find that this lever will then move. So I'll go and get this cleaned up. We'll have a quick look at it once I've cleaned it before I start trying to free it up, and we'll go from there. So after a good clean, the punch has come up very nicely. There is a little bit of rust on the paper tape guide. You could of course remove this, strip it and recoat it, but it's not too bad. I'll decide what to do with that later. Probably just take it off and clean it up. It is still jammed, it won't move, and usually something like this, the first thing to do if you haven't seen one before is figure out how it works. If you figure out how it works, it makes it far easier to free it off and get it working. If you just start poking and prodding, then chances are you're going to damage something. So what I did with this was give it a good cleaning detergent, rinsed it off, blew it out with compressed air at fairly low pressure. I then used a hot air gun to heat up these pads. These felt pads in between these levers are meant as oil reservoirs, but the oil gets fairly manky after a while. There's a few of these. There's one here, and there's one up here, and there's one at the back. And what I do to clean these out is just heat them up with a hot air gun, very carefully avoiding the springs. You don't want to retemper the springs, and as soon as this starts to bubble, you can just dab it with a bit of kitchen towel, and the oil will wick out, and then you can re-lubricate it and put fresh oil in there. The punch pins don't seem too bad. I can't feel any pitting on them. If you need to, you can take these out and repolish them, just a couple of screws on the bottom, then they'll all come out. Just be aware that there's one pin that's smaller, which is for the paper tape feed hole, so the sprocket hole is smaller. so it's a different pin, and that needs to go in the right hole, of course. And the rest of it is now just a case of freeing it up, and it should in theory work. As with the printer in this machine, this punch was well and truly stuck. Pretty much every pivot and linkage was binding or completely jammed up. It's taken quite a bit of persuasion to get it freed up, but it is now working quite nice and smoothly, so it's looking quite promising that we should be able to get this punching fairly quickly. I'll just quickly explain again how this works. I have explained this in a previous video, but I'll go into a bit more detail this time and just try to fully explain the way this behaves and the way the various parts work. One thing you'll notice with this is the pins are exposed on the front, and in fact a major problem I had with this was the pins were absolutely jam solid in the top part of the punch die, and took quite a bit of persuasion to get them out. They also look fairly blunt, so I may need to sharpen these and re-hone them. Hopefully not. We'll try and see if it punches first, but what tends to happen as they go blunt, it either starts tearing the paper or the amount of force required to punch the paper is excessive and it just won't punch it properly. What you can do, notice these two holes on the front. This punch was used in quite a few different machines. It wasn't just for the ASR33, and in some implementations there's a housing that sits on the front that is screwed on with these two holes, and inside that housing, especially a rectangular housing with a cutout inside a hollow section, and in that hollow section is a small piece of felt, and the idea is that you impregnate the felt with oil, it rests against the pins, you screw the housing on, and it keeps the pins oiled and stops them seizing up. So anyone that has one of these, I highly recommend making that modification. It will make the pins last a lot longer. Okay, so getting back to how this works, as I said, this is where power comes into the punch. So if you recall, on the side of the printer on the ASR33 there's a kind of a link rod, and that engages with this pin, and it just simply rocks back and forth, and one back and forth movement is a full cycle for the punch. On the top of the ASR33 there were 4 buttons. We'll come back to that in a few minutes. Another one here is to release the paper tension so you can feed new paper in, and then these 2 buttons are start and stop, or on and off for the punch. The way this works, it's a very simple lever arrangement. When you push the rear one, which is the stop, it causes this arrangement here to basically pivot this way. You've got this roller on the back and this kind of captive section on the front. And so the rocker arm that's responsible for moving this back and forth, it kind of rests here and it runs on this roller. Now when you push this rear lever down, it tries to push this lever down here, and as the next cycle starts, this link pin pops up into this recess, this roller comes up, and what it does is it lifts the drive arm out of engagement with this pin, and then it just sits there and it rocks back and forth on this roller and doesn't do anything. So effectively you've disconnected the drive for the punch. If you then push down the front, it this linkage allows the roller at the back to move back down, and that allows the drive link to pop back down and re-engage with the pin. So it's just a simple kind of on-off switch for the punch, disengages or re-engages. So as long as that's moving up and down, then it should be working fine, but of course it needs to be in the up position for the punch to work. What we then have is, the other thing to bear in mind with these is that the code for a particular punch cycle is set in the previous motion of the pin, so that's the only thing that can be confusing. So if you're testing this, you might find you need to move the pin twice for it to action the values you've set on the selector bars. The other thing with the selector bars is they don't all work in the same sense. So if we look on the underside of them, and again it's quite hard to see this, but there are these fingers, and each of these slides has more than one finger. The rest you can't really see that clearly, they're kind of underneath these levers, but depending on whether the arm is in or out, it will select a particular lever, or it may select a different lever. These are not all the same, so there is a degree of coding in these, because some characters are not punched. So for example, punch on and punch off are not characters that are punched onto the tape, and so this punch needs to be able to interpret particular values and respond to them accordingly. So there is some encoding on this, so just pushing all these in doesn't necessarily activate or deactivate all the punch pins. The way this runs through a cycle is when the cycle starts, the lever will, or the pin will start to come forward, and any of these silver levers, you can see them moving across, any that are engaged with this lever, when this lever is pushed down by the power bell, which is this bar here, will cause this lever to be pulled downwards. There's a rocker arm that moves across, a pivot here, and they engage with the bottom of the pins. So if I now cycle the punch, as those bars rock, and by default they are engaged, so as they start to rock you'll see the pins move up and then back down, and that's how it works. If you want to stop and that would punch all the holes of course, if you want to stop a particular pin from punching, then you just simply disengage this lever. So if I now hold that out of engagement and then we cycle back through, you'll notice that the pin on the left has not moved because its associated drive lever is not engaged with the power bell. When we go back to the end of the cycle, notice that this re-engages, so the next time round the pin moves up. At the end of the cycle, and this is an adjustment you may have to make, at the end of the cycle you have this lever down here, and it's responsible for pulling all of these silver levers back into their reset position. So if you watch this lever that comes down and it rests on the bottom of this kind of horn shaped lever, as we move through a cycle, at this point this lever with the kind of dog leg in it pops up. It engages with a cutout in the bottom of the silver link lever, and then when the cycle finishes and this pin is pulled to the back, it pulls all these silver levers back into their default position. The other function this performs towards the end of the cycle is we have this ratchet mechanism here, and one of the pins on top of the punch is used to manually feed paper, but it's feeding the paper backwards, so this is a backspace key. To forward space you simply do a feed from the printer, but pushing this button down will cause the paper to move back one character position. If we cycle the punch by moving the bar, you'll see that towards the end of the cycle, so now the pin's all the way forward, it's punched, all the pins are moved up, so it's finished punching, and as the pins move down and they come out of the holes they punched in the paper, this ratchet system will be used to feed the paper into its next position. So I'll finish off the cycle, the pull has engaged with the ratchet wheel, and then when we go all the way back it causes the ratchet wheel to be pulled around, and that advances the paper, pushes it out into the next position ready to punch the next row of holes. This lever here is simply used to push the paper guide chute down, and that disengages the pinch roller. You've got this roller here that's got the serrations on it, and the drive roller for this that's on the ratchet wheel is underneath that, and the paper is kind of pinched between the two. But when you push this lever down, it raises the serrated pinch roller, and this allows you to freely feed paper in, and that's used to load up paper. So what I'll do now is I'll load up a piece of paper and we'll see if we can actually punch any holes. Okay, I've got a piece of paper loaded. What I'm going to do now is try and pull this all the way through. So all the pins should punch. So they've all gone through the paper. Finish the cycle off, the paper should move forward. There is a lot of oil on here. I've been obviously soaking this in oil at the top end just to try and free it off. You wouldn't normally have this much oil on the punch head. I'll do it one more time. I'll now pull the paper through. And as you can see, it's punching. The holes are quite nice and round, and the oil needs drying off, of course, but I'm just trying to get this to free up without damaging the pins. So they're all punching quite nice and round, they're not jagged, so possibly the pins will clean up quite nicely, but they are, as you can see, all punching quite nicely. One last feature I just want to mention, I mentioned this in the previous explanation I gave on this, but I've been asked about it a few times since. As I move the punch through its cycle, if you're watching this area here, you'll notice there's a kind of a bulge appearing. If I take the paper out, then that bulge is caused by a lever. You can see there's a lever here that's kind of popped up, and it comes up quite a long way. What it's for, it's an anti-snatch mechanism, kind of equivalent to the sine drive on the facet punch we looked at. So what it's for, if you imagine this piece of paper has been fed from the paper reel. The paper reels are quite big and heavy, weigh about a kilo, so because at the end of the punch cycle the paper is kind of quickly moved forward to the next position. If this paper was tight and the other end of it was on a full reel, for example, then there'd be a lot of inertia on the paper reel, and because it's a friction drive, that sudden snatch would probably cause the drive roller to slip, or it might even tear the paper. And so what that lever's for is, at a certain point in the cycle, we've got the pinch roller holding the paper at about this position, and then that lever comes up here, and what it's for is to kind of slowly form a loop, and that causes the paper to unroll relatively slowly from the paper reel. And then at the end of the cycle, when the punch wants to pull the paper through, it can pull it through very quickly. The lever's gone back down, it's out of the way, so you've got this kind of loop of paper, and it allows the punch to then pull the paper through quickly. You've got very low inertia because you've just got this little loop of paper, and then on the next cycle it pulls up another loop from the roll of paper. Paper reel can rotate nice and smoothly and slowly, and then at the end of the punch cycle the punch can quickly move the paper forward. So that's what that's there for. It's quite a clever addition they made, and it stops the paper tearing or the holes being unevenly spaced. Without that, you'd either end up with paper ripping, or the holes would all be spaced randomly, and they wouldn't be able to be read properly in the reader. So ingenious mechanism, and quite easy to work with once you figure out how they work. It's just normally a case of lubricating them, cleaning them. Adjustments like this is just making sure that it allows proper engagement to reset. So if you find you're getting a certain random punching and it's not giving you the expected paper output, and there are various pins maybe that are punching all the time when they shouldn't, just make sure this is adjusted properly. All you do is you slacken off the screw, move this lever around, and this lever needs to cleanly engage with a little cutout on the bottom of the vertical link levers. Okay, so this is now ready to go back into the ASR33. We'll put it back in. Very easy to refit, it's just engaging these with the end of the code bars, putting the 3 screws in. There's a screw here, one here, and then one at the bottom, and the link lever will automatically re-engage once this has been refitted. So I'll get this fitted I won't video it, it's just a case of putting a few screws in, but we'll then try punching some paper. Okay, I've got the punch refitted to the ASR33. I've got some paper loaded, so I'll zoom you into the punch and we'll try pressing a key and see what happens. Okay, well I haven't tried this yet, so I don't know what's going to happen. I'm going to turn the ASR33 into local mode. And I'm going to try and press a key. Try another one. Okay, it's kind of working. It is punching correctly. It's punching the holes I would expect, but it's not properly feeding out the paper. I think we've got an issue with the paper feed. I think what's happened is I've got a feeling the channel has been kind of squeezed up somehow, so it's very tight and it's not freely feeding the paper through. I can feel it when I try and pull it through. It's extremely tight. So I'll get that tidied up and get the paper moving freely. As I say, it's just this top end, it's just this little guide up here that's not allowing the paper to come through cleanly. So I'll get that cleaned up, get it adjusted. Okay, I've cleaned up the paper tape chute. It's just the guide was bent in. I'm not quite sure how that's happened, but it was pinching the paper, preventing it moving freely. Still a little bit tight, but I'll give it another go now and we'll see if it's any better. Okay, it's a bit better, but clearly it's not right yet. So I'll keep working on this, try and get it properly freed up. I just need to get it freed up. It's kind of pinching here and it's not properly aligning with the punch head. So I'll get this sorted out and we'll try it again. Okay, I couldn't get the paper feed to work as it should do. It was binding up. It was better after I'd cleaned it a little bit and used it, but it still wasn't feeding properly. And it really comes down to this guide plate that had the rust on it. It's too rough, it's kind of grabbing the paper and preventing it moving smoothly. So what I'm going to do is basically I'm going to have to strip this right back and see if I can refinish it. I'm not going to paint it, at least I don't think I'm going to paint it. I'm probably going to blue it, or at least basically black it. I'm going to take it through bluing through to full black. So that will mean polishing this face completely till it's like a mirror finish, and then heating it until a very thin oxide layer builds up. Essentially what's on there now, it's there's no way I can get this polished up without marking it, and if I go through this protective oxide layer it will just rust again in a day. So I might as well strip this right back. I'll show once I've polished this up so you can see what it looks like, and then we'll go through the bluing process and hopefully get something that doesn't look too bad. As I said, there's no way to recover this really other than do this. I don't want to paint it. If I try painting it, because the paper is quite abrasive and it's likely just to rub the paint off, and we'll be back to having an issue with chunks of paint getting into the punch head. So I'll get this cleaned up, we'll have a look at it and then try and blue it. Okay, I've stripped the original coating off and I've now polished this up. I used 400 grit abrasive paper to get the worst of the pitting and rust off. I then used 3000 grit to get a very nice shine. There is still a bit of pitting, but not too bad. Now I can't leave it like this, of course. Firstly, it doesn't really look right, but also it would rust very quickly. So I'm going to turn this black, basically the bluing process, but all the way through to black. So I've cleaned this with isopropyl alcohol, any grease at all, and this won't work. And what we're going to do now is heat this up. I normally use an induction heater for this, but you can't see inside of it, or at least not with the camera. And so I'm going to use a hot air gun so you can see the process. Still quite difficult to see, but I'll try and get it as clear as I can. But the basic process is to start heating this up, and as it starts to heat it will start to develop an oxide layer, and it will start by turning a very pale straw colour. It will then go to a deeper brown, then on through purple, blue and onto black, and it's the black that I want here to try and match the original. As I say, I'll try and get this on camera, but it's not going to be particularly easy. But it's going to get a hot air gun. I'll subdue the sound a little bit. Okay, well I don't know how clearly you could see any of that, but it went through, and I've stopped just as we got to black. You could go further and take it a deeper black if you wanted to, but as it goes through these colour changes, if you want to stop at a particular colour, if you want it deep blue for example, then as soon as you have it that colour, drop the piece into a glass of water and cool it down, and as soon as you cool it down it will retain the colour it's achieved. So we've got a slightly blue-black here, which is the colour it originally was, looking at the reverse side of it. So I've decided to leave it that colour. The rest of it is black, or at least most of the rest of the parts are kind of a deep black. And what I'm going to do now is the same process with the roller. That's not too bad, but it is relatively pitted, and a lot of the coating has worn off anyway. So I'll do the same with this, and then I can reassemble and see if we're any closer to having a working punch. I thought I'd show this process. It's quite interesting, and it is a useful technique if you don't want to paint something. And painting, because this is not an added coat, it's effectively the surface layer oxide built up onto the parts, so it's not going to very easily wear off, and it's extremely hard wearing. So unlike paint, it's not going to flake off and cause problems. And this is very similar to what they originally did anyway. Okay, so that's the roller stripped. I'll now heat treat it in the same way to give it a black finish, and I can then reassemble the punch and see what happens. I won't show this process exactly the same as I did with the plate, but I will show the roller once it's been completed. Okay, so that's the roller finished. That's now nicely coloured, and of course it has the protective coating on it, so it's nice and smooth now. It's all the pitting's gone, and that should run much more freely and shouldn't grab the paper. While I had this assembly out, I decided to strip it down and clean all the other bits, and I'll now reassemble this, put it back into the punch, and see if we've made any progress. Okay, that's the paper tape guide refitted to the punch. I'll get the paper reloaded and see if it works any better than it did. Okay, I'll power it up and try pressing some keys. Okay, well that seems to have resolved the problem. It now appears to be punching, It's also punching very nice and evenly, so what I'm looking for is very even spacing of the rows of dots. It also seems to be punching the correct sequence of dots. Punching quite nice and cleanly as well, so no excessive noise, no excessive vibration or banging coming from the punch as it's punching. That would indicate blunt punch pins or something like that. So it's looking like this is now working. And so the main problem with this was just the rust that was in the paper guide, and the rest of it before that was just freeing it up, and it now looks quite nice and actually works. So in the next video we'll look at the paper tape reader, and we're getting very close now to having this unit complete.